Hello everyone. In this video we'll be talking about designing agentic systems, and we will introduce a use case or a problem, and we will think together how to solve this problem using different ways. We will discuss the pros and cons for each of these ways, and hopefully by doing this you will learn how to encounter such problems and how to think about the design of your graph. So there are infinitely many ways that you can create a graph that contains the same agents, either by changing their position in the graph or changing the way they can communicate to one another. So we'll be discussing this, and yeah, hopefully you will learn how to design a graph. So this video or this lesson consists of multiple videos. So this one we will go through different graphs. We will comment on each of these implementations without showing any code. And in the next video, we will go briefly over the implementation of these different graphs. So yeah, let's dive in. So first things first, let's define the problem that we have. So we want to create a system that helps you writing a publication. We call it Agentic Authoring Assistant, A3. And the purpose of this system is to take some input from the user about the publication, and it should generate a title. It should generate a TLDR section, which is basically a concise summary about the project, and it should give you some tags and some references. So yeah, we want to create an agentic system that will be able to do this, and each of these components should be its own module or its different agent. And these agents should be able to communicate with one another, or at least have some common instructions, because we don't want these agents to be running independently. For example, it might give you a title that has nothing to do with the TLDR, or the tags might be very far from the main theme of the publication. So we want to implement the system. We want these agents to be able to communicate, and we will discuss different graphs or different ways of organizing these agents. And yeah, we will take a look at the pros and cons of each of these graphs. So now that you know the problem, the first thing that might come to your mind while working on this is, why don't we use like a simple chain like this one here? And by the way, to implement this, you can do it in LangChain. You don't even need LangGraph. It's just chaining LLM calls. And the problem with this approach, there are actually two problems with this approach. The first one is these agents run independently. They have no idea that the other agents exist. For example, the title generator, it's going to give you a title, and this title has nothing to do, might have nothing to do with the TLDR tags or references. There might be some misalignment, because from the point of view of this agent, it's just responsible for giving a title. It takes an input, it gives you a title. It doesn't know that the TLDR generator exists, for example. And why is this an issue? So it is an issue because each one of them is running independently. So for example, let's say that the user wants to write a publication about transformers or LLMs. And the transformers is a subset of deep learning, for example. So the title might be about transformers, but the tags might be looking at the bigger picture, like deep learning, optimization, Adam optimizer, which is, in general, they are good tags. They are related to the transformers somehow, but yeah, it's looking at the bigger picture. It's looking at deep learning in general. So the output from these two nodes are not going to be aligned. And yeah, this is the problem with running them in a chain this way. So they don't know that other agents exist, and basically they are not aligning their outputs. So this is one problem. The other problem is they have to run one after another. So you cannot parallelize if you yeah, create a graph like this. So normally these things can run in parallel because they are somehow independent, but they also should be looking at each other's outputs. So yeah, this cannot be achieved through this solution. So you might think, okay, since a simple pipeline or a simple chain does not work, then we might want to add a reviewer agent that takes in everything that comes from these agents as an input, and then revise it and give feedback to these agents if some agent needs to adjust its output. And on the first sight, this seems reasonable, but it has a very bad problem, and that problem is, imagine that all of these agents gave very good results except for the title generator. So the reviewer is going to give feedback to the title generator to change its output, right? And after the title generator changes the output, it has to go through the entire pipeline again. So everything has to run, and then you give it back to the reviewer, and revision is happening again. It might go back to one of these things, and the entire pipeline runs every time, even if it's a single agent that needed adjustment. So yeah, it looks like the reviewer idea is good, but this structure of a graph it will not work well, and it will cause a lot of unnecessary changes happening in a lot of these components. So it's going to be actually harder to converge, because each iteration, each of these agents might give you something new, and yeah, every iteration, a lot of things are changing. Not only the output of the agent that the reviewer is talking to. So with a lot of changes, it might be hard to converge, because every iteration, a lot of things changes, and the reviewer might keep on giving feedback to these agents for a really long time. So given what we discussed about the previous two approaches, you might think about something like this. So the main problem that we discussed with this approach and the approach before it was that these agents run kind of independently. They have no idea about each other, and each of them is just running. So we want to solve this problem. So we start introducing what we call the manager node, right? And this node gets the input from the user, which is the initial information about this publication, and it writes like the main theme or the main points that each of these agents should take into consideration while working on that publication. So remember the example that we gave regarding deep learning and transformers. Well, this problem is not going to happen anymore, because the manager is going to give something like very general instructions that all of these agents will see. For example, one general instruction might be focusing, like asking the agents to focus on the transformers, and not giving much attention to the higher level concepts of deep learning or optimization or yeah, these things. So now that all of these agents have the exact same general instructions, all of them can run in parallel this time. So this is another difference between this approach and the previous one. Here they had to run one after another, while here all of them can run in parallel. All of them get general instructions, and each node of these have its own special instructions as well. So after all of them are done, they send their results to the reviewer. And here there is a connection between the reviewer and each of these nodes. So it's a yeah, in both directions, I mean. So the reviewer reviews everything, and it can decide to send to one or more of these agents for feedback. For example, it might decide that title generator needs to adjust, and the tags generator maybe also needs to adjust. So in this case, only these two will run. The TLDR generator and the reference generator will stay the same. They will not run again. And these two will keep on refining until the reviewer agrees, and then yeah, the execution ends, and now you are yeah, left with the title, TLDR, tags, and references. But this time the results should be coherent, because they should be talking about the same thing, given the instructions that the manager gave to all of these nodes. That's it for this video. In the next one, we will briefly go through the code implementation of this agent, and we will show of this multi-agent system, and we will show the state that we used. And we will also give some insights about the pros and cons of this approach itself. So I hope you like this video, and I'll see you in the next one.